I often get asked, well, who is 7G? What is 7G? Obviously, our name comes from a constitutional philosophy of sustainability. But then I usually follow that up with that we're a technology company. A technology company that sells energy in the form of hydrocarbons. And so, I guess, why innovate? Why does 7G spend so much money on R&D, whether it's in our wells or completion styles or facilities? Well, when you have a conventional play and you have tens, or if you're lucky, hundreds of wells, to innovate and spend R&D capital on your first 10 well to have a benefit on your last 10 probably doesn't make a whole lot of economic sense as far as NPV on the project. But when you have a conventional resource like we have in the Montney, where you have thousands of locations, any incremental either cost savings per well or on facilities or improvement in productivity in your first 100 wells has a huge incremental benefit on your project NPVs. And it's one thing that has been ingrained in 7G since quite frankly, we founded the company almost 10 years ago. Everything we do has an innovation bent to it. So we talk about our capital spend for next year. Most of that is in R&D, whether it's on the drilling completion side, the facility side, the operations side, or even marketing. And so when we're looking at this, I'm just going to walk through some of the points. When we're looking at subsurface technology, and Lynn will get into this in more detail, but we have over 2 kilometers of Montney core where we've done detailed reservoir analytics to determine porosity, permeability, water saturations, geomechanical modeling on that. And that all goes into what to determine oil and gas, or gas in place, to calculate how the geomechanics go into our frac propagation models. How are these fracs propagating? We talk about some of our completion design changes. All that goes into that to help us come up with a reservoir model. We talk about our PhD reservoir engineer. He sits there and cranks this out. And we're able to come up with predictions on what the wells are going to do in the future. So there's a lot of innovation that goes into everything that we do at 7G. On the drilling side, we talk a lot about our real-time operations center, where we look at our fleet of rigs, whether it's 7 that we're currently doing or going up to 10 later in this year. And every change that we have, whether it's slight tweaks and underbalanced drilling that we can apply it across the whole fleet, or changes in our bit design that we can apply and improve our ROP and shorten the time that it takes to drill. On the completion side, I know some of you guys have been up to and toured our facility up in Grand Prairie. Some of you may not know that half our staff are actually in Grand Prairie. Most of our technical staff is in Grand Prairie. It has always been a philosophy at 7G that we need boots on the ground. In order to implement a lot of these efficiencies, and being 45 minutes away from our field, a lot of our staff spend a lot of time out there. It's one thing to make changes in Calgary and hope they get implemented. It's different having engineers on site. Our completions, we have about 25 completion engineers. And so they monitor every one of our fracs. And it's not to change wholesale design changes, it's making slight tweaks on the fly to make sure that we can have efficient placement of our proppant. On the operations side, operations are usually, well, keep the well flowing, and facilities are usually pots and pans. We look at that quite a bit differently. We've had a very innovative approach to our facilities design. We talk a lot about our super pads, and that's distributed compression across our field, which allows for artificial lift because we knew we'd have high liquids. And having gas lift at each one of our pad sites allows us to lift up liquids for the long term, knowing that the liquids are going to drop out because we do have different gas and condensate declines. So that's one of the innovative things that we see. And one of the things I will talk about when we get into some of the efficiencies is our facility cassette design, which is an in-house sort of plug-and-play design for a well module, which could save up to 25% in well tie-ins. And then lastly, marketing. When we were 8,000 BOE a day, we had line of sight to over a BCF of gas production, and we were able to very confidently determine that we needed a half a BCF of firm service, and we took that on the alliance. And I know that Tim and Charlotte and Lyle will come and talk some of our marketing initiatives recently, and it's about getting premium product for the products that we sell and improve our netbacks. So on that, I'll pass it back over to Lynn to go into some of the subsurface technology.
Thank you. I'm just going to spend the next 3 slides just talking more on the subsurface technology that we're applying at 7G. So really, we look at it, we try and build a really integrated 3D model. That's what we try and achieve, to use all the subsurface technicals so that we have the best understanding of our reservoir. And that includes utilizing 3D seismic. With 3D seismic, we can do attribute work and understand the pore volume fluids, reservoir characterization. And in addition, we can understand where we have probably fracturing and better permeability. So that's an advantage. As Glenn mentioned, we've got about 2 kilometers of core, and in fact, we brought some core here today, and we have a geologist, Dan Hayter, who can answer any questions you want about that core. So feel free to take a look. It's going to be in the lobby. But from that core, of course, we get our reservoir parameters. We also can test things like produced water on our core. So we know that we're not going to be impacting the rock when we want to go down the path of putting produced water. And we've been doing those sensitivities, and we're seeing good results from those. So that's real positive. Again, understanding geomechanics will help us with our completions, and geochemistry in general to understand where the hydrocarbons are being sourced from. All of this information goes into an integrated 3D cellular model, and with that we can understand our volumetrics, how much gas in place we have, how much liquids we have in place, and then we can place our wells and lay those out and plan them. And next year in 2018, we're going to be adding to this technical story, and we're going to be running what we call a tech pad. And essentially we're taking 3 laterals, which you see on the slide on the map in pink, and we're going to be applying microseismic, microdeformation, fiber optics, and pressure gauges to these 3 wells. The well in the middle is the monitor well, and essentially that's going to subsequently be a water disposal well. But with that monitoring, we're going to be able to optimize our spacing, evaluate our completion efficiency, determine if we have well interference, and essentially with the fiber optics do real-time monitoring of the completion itself, and then over the long haul of the well, the production. It's amazing technology. This is an example of the fiber that we put. So this top picture is a lateral well, and the fiber sits on the outside of the casing. And essentially, when you are completing the well, we're going to be able to measure the volume of proppant that leaves the wellbore and goes into the rock. And we can do this with digital acoustic sensors, and that's what you see. The blue and red picture up there is showing where the acoustic sound is, where the proppant is entering the rock. So really, really good information for us to be able to model our fracking. And then the bottom picture there is showing when you actually are producing the well back. You can see when where the production is coming from, and we can actually monitor those declines through the life of the well. So essentially, we're going to be able to build a calibrated frac model. We can tie that to our reservoir model, tie that to production, and then ultimately tie that to economics. Run sensitivities on spacing, and accelerate these engineered learnings so we can optimize our resource recovery with the best capital efficiencies.